This is problem 112, Neetcode 50, longest common subsequence. So in this problem, we're given two strings, text1 and text2, and we have to return the longest common subsequence between the two if they exist. Otherwise, we're going to have to return a 0. So basically, what is a subsequence? A subsequence is basically, well, let's just take a look at this example. Let's say this is text1 and we have cat, and text2 we have CRABT. Well, what really matters is not necessarily that we have C, A, and T adjacent to one another, but that we have the characters C, A, and T appearing in the order C first, A second, and T third, right? So in CRABT, we can see that we have C and we have A appearing after C, and then we have T appearing after T. So this is exactly what's happening. All right, so this is a dynamic program problem. So we're gonna do dynamic programming in a 2D grid. So let's see how this works. So let's say we have the words A, B, and C, and we have A, M, B, V, C. So we can see that the greatest common subsequence is going to be A, B, and C, right? So this is I will show you basically the core of dynamic programming. So what we're going to do is that we are going to start from the end of this grid. So initially we're going to create a grid like this. So basically we're going to have both strings that will be the length and the height. And we're going to start at the bottom right. And what we're going to check is we're just going to, and let me just add a 0 here. Notice that I have created zeros on basically the outer bounds. This is something that we're going to have to do. You'll see why. So let's just follow the flow of the dynamic programming 2D solution. So first, we're just going to check on the bottom right corner if both characters are matching. Is C and C the same? Yes. So if it is, we're just going to add 1 to the value that is diagonal to it. So this is going to be 1 plus 0. It's going to be 1. And now we're also going to loop for every single columns for every single rows. So we will do this also in a decreasing order. So we're going to go from there, then there, then there up to the top left corners. And every time we are going to check first if the two characters are matching. So now we're moving to this particular cell, and we're just going to check if C is basically the character B, and if they're not matching, we will be willing to take the greatest value between the value to the right and the value down. So we can set now the case here is going to be either 1 or 0, and since we're taking the greatest value, we're going to take 1. And same thing for here at this value C. We're just going to check if C is the same as A. Is it? No. So we're just going to take the greatest value to the bottom and to the right, and this is going to be equal to 1. And basically, the core idea is that once we find that at this particular place there is one character that is matching, we know that for the rest of this of the two substrings, we're gonna have at least one character that is gonna match. So I'm just gonna draw one everywhere. This is not exactly what's gonna happen, but it is just to show you basically the logic of the solution. So once we are done with this particular case, we're just gonna go one row up. So we're gonna go see this case, and we're gonna see if C is matching V, and it is not. So since it is not, we're just gonna take the greatest value between the right case and the bottom case, and it is 1. We're gonna do the same thing here. Is B the same as V? No. So we're gonna take the greatest value between 1 and 1. So it's gonna be 1. Is V the same as A? No. So we're just gonna take the greatest value between bottom case and right case. All right. Now we're gonna go here, and we're gonna see that B is not the same as C. So we're gonna take the greatest value between the bottom case, which is 1, and the right case, which is 0. And now we have another case where we have two characters that are matching. So what I will do is that I will just add 1 to the case that is diagonal to this case. So it's going to be top 2 plus 1, which is going to be it's going to be 1 plus 2. So it's going to be, well, 1 plus 1, pardon me. I had a hard time spelling that, but it's going to be 1 plus 1, so it's going to be 2. And basically all the other cases from this point um, could be set at 2, because we know that at the worst cases from this very point, um, we know that we're going to have at least 2 characters that are matching. But we're just going to keep going still. We're going to go here at this case where we have B on the left side and A on the horizontal side. We're going to see that they're not matching, so we're just going to take maximum value between the right case and the bottom case, which is going to be 2. We're going to go do the same thing here. And we will keep doing this basically until we reach another characters that is the same. So we can see that both A's are the same. So we're just going to add 1 to the character that is diagonally down to this. So it's going to be 1 plus 2, so it's going to be 3. All right, and now notice that the top left case is actually going to give the answer that we are looking for. So this is how we are solving this problem in a 2D dynamic problem. So let's go ahead and code this now. So the first thing that we want to do is that we want to create our 2x2 grid. So let's go ahead and do this. So I'll call this dp, and this is going to be basically equal to so I want to have rows for g in the land, for g in the range of the land of the text2, as the text2 is basically the land of a single row. So yeah, so text2 plus plus 1. So now we're gonna have basically all the zeros we need per column, and we also have to set that basically for I in the range. Now we'll just put this on another line so it is cleaner. So for g in a range of the line of text1 plus 1. All right, so now we have basically our 2x2 grid, and all the cases are set to 0 initially. And first thing we're going to do is that we're going to go for all the rows and all the columns. So I will say for row in the range of the len of text2 and text2 plus 1. And actually, we want to do this in a reverse order. So I will be willing to reach basically the bottom right cases. So we're gonna have to say that we want to reverse this, and we are going to do this by adding this -1, and this value here is basically to say that we are going up to the index 0, because that's setting our boundary index. So now we're going to say for c in the range of len of text1 and we also want to subtract 1 to this. We want to bound this to the index -1, and we want to do this in a reverse order. And what we will do, so we're going to check if both cases are have the same character. So we're going to say if text1 at the index I, or not I, pardon me, at the index row is equal to text2 at the index C. So in this case, we're going to set this particular cell's value. So dp row column. This is going to be equal to 1 plus the value of the cells that is diagonally down to this. So it's going to be the dp row plus 1 and column plus 1. Okay, if they are not the same, we're going to basically take the greatest value between the case that is at its right or at its one case down. So dp at this row and at this column is going to be equal to the maximum value between dp um, rel and oh, c plus 1, so it's the value to the right, and then dp r plus, well, plus 1 and c, right? So that's that's it. That's basically the 2D dynamic programming solution. At the end, we are gonna return the DP at the top left, so at the index 0, 0. Um, and that's it. So we can submit this problem. We have an index out of range. So yeah, of course, I actually messed up these. So basically, um, the rows are, well, we want to use the text one for the rows and the text two for the columns. So this should be enough. Let's test this out. Yeah, okay, that was it. Awesome. So you can see that this is a pretty good 2D programming solution. We're going through every single cells, so we're gonna have a space complexity and a time complexity, both to big O of m plus n, where m is the length of the substring of the string 1, and n is the length of the string 2. So I hope you learned from this video, and I hope to see you in the next one.